Hello, good people. Welcome to video number 3. Before I go on to the third example, I do want to bring up 2 points. The first point is always read the directions, because if you read the directions, it says set up the equation for each question and use a calculator to solve it. So when I did letter A, I did the whole fundamental theorem of calculus step, which is not bad because we remember that if you ever have a definite integral and you can find the antiderivative of the integrand of the thing inside the integral, then you can do the fundamental theorem and get an answer. So our answer was all of this business, right? And I didn't simplify it. I just said, oh, that's what it is, and that's in feet. But the direction said, hey, you can use a calculator. So I don't want to not remind you that you can use your calculator on part of the test, right? So if you are on the calculator active problem, if you're on a calculator active problem, then set up the equation, and then one of the four allowable functions on the calculator that you can do without any explanation is the definite integral option. And so we can go, we'll make a little fraction. We'll say that integral of 1/3 times the integral, which is math 9 from 0 to 3 of, now here, I think it was negative 16 t squared uh, plus, oh, what was it? 41? 41t plus 10. Yeah, that's what it was. 41x plus 10, and then dx. And I got 23.5. So 23.5 was the average height. Now, in the second problem, the other thing I wanted to point out is in the second problem, we figured out this question by using the height formula, realizing that it's asking for the average velocity, so it's asking for the average rate of change of the height. So we did the average rate formula. However, if I had the velocity function, I could have done the average value of a function formula, which we did in letter A, but that means I would have to have the velocity function. But can I get the velocity function? Well, yes, because the velocity function is just a derivative of the height function. So that would be negative 32t plus 41. That would be the velocity function. And now I can use the average value of a function formula and say, oh, this is 1/3 times the integral from 0 to 3 of this function, tt. And this should give me the same answer as we got over here. And if I go to my calculator, we're taking the average value, we're finding the average value of the velocity using the velocity function. Then I can say, oh, that's 1/3 times math 9 from 0 to 3 of negative 32t plus 41. I think that's what it was. And when I press enter, I get -7, which is exactly the answer I got doing it the other way. So again, the whole idea is pay attention to what you're given, which one's more convenient, which is more efficient. If I use the average rate of change formula, that's just a slope formula because I'm finding the average rate of velocity, which is the average rate of change of the height. Okay, let's keep going. Number 3 here. R of x is equal to this trig function, where r is the rate at which Mr. Brust's waistline is changing in inches per month, and x is time in months. What is the average rate of change that Mr. Brust's waistline changes from the 10th to the 12th? Okay, so this is going to require you to pay close attention to what you're given and what they want. They want the average rate of change that the waistline changes. But the equation that they give us is the rate at which the waistline changes. So I'm looking for the average value of this function. Do you see that? My equation is a rate. I'm looking for the average rate. So therefore, I'm looking for the average of this function. So that's going to be from month 10 to month 12. So that's going to be 1 over 12 minus 10 times the integral from 10 to 12 of 2 sine x minus 1 dx. This is what I'm going to need to find. And I'm going to use my calculator to figure that out. Now that I know and I've read the directions that I can use my calculator. So I go to my calculator and I clear this, making sure that we're in radian mode because all of our trig functions have to be in radian mode. And I can substitute and do this. Okay, so it was 1 over 12 minus 10. I can just say 2. And then math 9, the integral from 10 to 12 of 2 sine, oh, sorry, this should have been 10 to 12, 2 sine x, and I believe it was minus 1, 2 sine x minus 1, minus 1, and that would be dx. Bammo. Negative 2.682, negative 2.683, I guess, negative 2.683. Remember, they're always going to check to see if your answer is accurate up to 3 decimal places. You can go more decimal places, that's fine, but it has to be accurate up to 3 decimal places. So if you cut it off at 2, they're going to count it wrong. At least 3 decimal places, it has to be accurate to 3, and it can be accurate by rounding or by just truncating in the 3rd decimal place. Okay, this is the average rate of change. Now, what was this? What was this units? What were the units of this? Well, we found the average rate of this function, and this function was measuring the rate in inches per month. And we're done. So Mr. Brust's waistline is decreasing at a rate of 2.683 inches per month between month 10 and month 12. Maybe he started working out at the beginning of the year. By the time we get to October, hey, he's losing some weight. What is the average change of this rate during the first 5 months? Okay, so now this is different because we're looking for the average change in the rate. Well, this is the rate. So we're looking for the average rate of change of this function. So we could do this formula and just say 2 sine, and then the first 5 months, 2 sine 5 minus 1 minus 2 sine 0 minus 1 divided by 5 minus 0. Why 5 minus 0? Because we're looking at the first 5 months. We're doing a slope formula. That's all we're doing. Excuse me. And we're doing the slope formula because we're looking for the average rate of change of this function, which is the rate function. So we're taking the rate of the rate. So I'm using the average rate of change formula, and I'm going to use my calculator to figure this out. I notice, by the way, that if I do 2 sine 0, 2 sine 0 is 0, so that's gone. So really, this is just going to be plus 1. Oh, wait, but minus 1, that's a plus 1. That's going to cancel with this, so that's gone. So really, I'm just left with 2 sine 5 over 5. All right, let's go figure this out. What is 2 sine of 5 divided by 5? Bammo. So, excuse me, the rate of change of the rate is negative 0.384. We'll say 384. 384. Now, what are the units? Well, what are the units of the top function? Well, that was inches per month. And then what are the units of the denominator? Well, the denominator was measuring time, and time is measured in month. So the rate is decreasing at a rate of 0.384 inches per month per month. I guess you could say inches per month squared if you want to do it that way. But that's how we can apply the average value and the average rate of change. They sound alike, but they're two different things. You have to be mindful of what you're given and what you're looking for to use the appropriate thing. Again, if you wanted to use the average value of a function for the second part, if we found the derivative of this, we would have the change in the rate, and then I could just find the integral there.